This recording is on Chapter 5 1 to 5.3. It covers if-else statements, relational operators, and logical operators, also called control structures. If statements are called conditionals. Logical expressions are when you use ands and ors. So flow of control can be broken down into the following categories. Sequential, which is one statement at a time from top to bottom, unless a control structure is used to change the order. And as far as control structures are concerned, there's two different types. There's selection, branching, which is your conditional, your if-else, and repetition or looping, which is a while loop or a for loop. Sequential control is just when the statements are executed one at a time. All of them are executed no matter what happens. Selection or branching control is when you ask a question or an assertion. That assertion evaluates as true, then the statement that follows that if statement is executed. If the statement is false, then the assertion is false and the statement that follows in the else part is executed. After all of those statements are executed, the program flow returns to sequential. So your if statement syntax in C++ is the following. You can either have an else statement or not. Either way, you're asking a question that results in a Boolean condition, which is a true or a false. If the result is a true, then the statement that follows immediately gets executed. If the result is a false and you have an else, then the statement that follows the else is immediately executed. In C++, if you leave the curly braces off, then only the very next statement gets executed for the if statement. If you want a block of statements to be executed if the if statement is true, then you need to use the curly braces to denote a block. If you leave these in this example, if you left the curly braces off, you would actually get a syntax error, because this statement would be executed with as if. This statement here would always be executed, and then the else won't know what if it's supposed to go with. So in this case, you will get an error, and it would be a syntax error. Here's an example just showing how you can use the braces or not. If you have one statement, it's safe to go ahead and leave the brackets off. More than one statement that follows your if or your else, you need to add the curly braces to indicate it's a block. So let's say x is 5 and and y is 10. So this statement, 5 is less than 10, is true. So z equals 6, and it would print out x is less than y in your statement. If, let's say, x is 10 and y is 5, then this statement is false. It skips to the else and just executes what's here. It's going to say greater than or equal to y. Here's another example. Let's say the year is 2020. Year mod 4 is equal to 0 because it divides evenly by 4. That means it's possibly could be a leap year depending on other criteria. If it's false, it's definitely not a leap year. So it's either going to print one or the other. Things to look out with control structures. We get so used to putting semicolons at the end of the statement with C++ that it's very easy to put one at the end of an if statement. And if you do that, it doesn't work as expected. You don't need a semicolon after the if statement or the else. You should not put one there. The compiler will interpret a semicolon after the if statement as an empty statement. If x is less than y, then do nothing. That's what this does. And then it's always going to print hello. So indentation means nothing in C++. Nothing. What it's looking for is a statement that follows the if statement that ends in a semicolon. So just be careful that you don't accidentally put the semicolon there. If you're checking for equality, you always use two equal signs. One equal sign is assignment, and in C++ this is valid. It will not give you a syntax error. It won't give you what you think it might not give you what you expect though. This actually sets x equal to 6. You'll either get a 1 or a 0 or some number, and in C++ if it is a number that's other than a 0, it's true. So this always will be evaluated as true no matter what x is. So you need double equal sign, like here. There's a double equal sign here. That's like saying check to see if year mod 4 is equal to 0, not set year mod 4 equal to 0. So just keep in mind that C++ is not going to give you an error if you use a single equal sign instead of a double equal sign. So different control structures in C++. You have an if, you have if-else, and a switch, which is a special kind of an if-else statement that we haven't covered yet, but we will later. And we have for loops, while loops, and do-while loops in C++. Now I don't teach do-while. We focus on while loops for most looping. For loop is a special loop that we use for arrays. Switch will teach you once we get really down into how if-else's work. Logical expressions are when you use control structures to make a choice. So you have relational operators. Less than or equal to is included. Greater than or equal to is inclusive. That means you're including the number that you're comparing it to. Equal is two equal signs. Not the same as a single equal sign. Not equal to in C++ is the exclamation point and the equal sign next to it. Then there's three logical operators. Not is the exclamation point, and is two ampersands, and or is two pipelines. And the pipeline on your computer, if you look at your keyboard, it's between the backspace and the enter key, and you use the shift key. So it looks like it's the / key. When you do shift, it looks like a pipeline. It looks like two vertical bars with a gap between, and you need two of those. Well, using one actually means bit shifting, so you need both of those operators to perform an and an or. So there's your 6 relational operators again with some examples. You can compare two variables to see if one is greater than or less than another. You can have an expression that evaluates as long as you know the values of a, b, and c. You can use a function like absolute. That will take, so you can apply a function in an expression, take the number, it'll make it positive, and then check to see if it's equal to 35. You can check to see if a character is equal to, not equal to an actual literal, like a Q. Just remember, characters are single quotes, strings are double quotes. So you can compare a string with a name. So given these examples, you have x and y, they're integers. We initialize x to be 4 and y to be 6. This expression, does it get evaluated as true or false? If x is less than y, should be true, right? What about x plus 2 is less than y? 4 plus 2 is 6. 6 is not less than 6. 6 is less than or equal to 6. So it would be true if there was an equal sign after this less than symbol. Right now it's false. Is x not equal to y? The answer is true. They are not equal. Is x plus 3 greater than or equal to y? 4 plus 3 is 7. 7 is greater than 6, so that's true. Is y equal to x? No, they're not equal, so it's false. Is y equal to x plus 2? Yes, they are equal. What about this one? Y equals x plus 3. Now be careful here. What do you think it is? The answer is actually going to be evaluated as 7 because x is 4. 4 plus 3 is 7. That it gets evaluated as true. So no matter what the value of x is, this result is not going to test to see if y is equal to 7. It sets y equal to 7. So be careful, you need two equal signs here. It won't give you a syntax error. It'll just might not evaluate the way you expect it to. Here's another one. If you have x is 12 and y is 2, we're checking to see if 12 plus 3 is less than or equal to y times 10. So we got 15 is less than 20, so that's true. Here we have 23 is less than or equal to 20. That's false. Here we have 10 is not equal to 10. That's false because they are equal. Here we have 20 is equal to 20. That should be true. And then 103 is greater than 50. That's true. I'm going to stop here and then talk about ands and ors. Oh my God. Where is it? Am I not recording it? Here it